Now let's do one example on how to create distributions, how to create histograms from quantitative data. For this example, we're going to do question number 12, and then we're going to use data file SAT. So this is the question. So we have a data file that contains a list of SAT, a sample of SAT scores, and we are asked to create a frequency distribution and histogram. And we are, for this specific question, we are given the specific values of the bin range. Well, basically the lower and upper bounds of bins. So the first bin starts at 800 with a bin width of 200, and it goes all the way to 2400 because this is the perfect score, right? So that's basically the maximum possible score. So 800 all the way to 2400 with the bin width or bin size of 200. And then we're going to comment on the shape of the distribution and see if we can make any observation, any specific observation on our histogram. So just going to go to the data file SAT here. So this is the list of the scores. As you can see here, we have 30 data points. So again, like whenever we're doing the histogram, using the histogram tool from data analysis, the first step always is actually establishing the bins. So I'm just gonna go ahead and write down the bins or bin range. And then when we're dealing with the bin range, whenever we're using the histogram tool, we only need the upper limit of each bin. So, and then the bins, actually our bins start from 800 and the bin size is 200. So the first bin is 800 to 1000, right? So starting from 800 with the bin size of 200. So actually the upper limit of the first bin is 1000. So I don't need the lower bound. And then I just need to increase by 200. That's my bin size. And if I just go ahead and continue that, I just need to go ahead and stop at 2400, right? So this actually characterizes the bin range. And now I just need to get the frequency and the histogram. That's all I need. For that, I need to go to the data tab, data analysis, histogram tool. So input range is the list of data points. So A1 to A31, and then bin range is the list of the bins. So C3 in this case for my data file, I started at, I put my bin range at C3 and to C11. And as you can see here, A1 and C3, these two cells are labels. These are not numerical values. It's very important to check label here. And if when you do that, the first cells from these two columns are going to be excluded, and they're going to be actually identified. They're going to be used as headers, as labels. And then I'm going to put the output in the same sheet. Let's say E3. It's going to repeat the bin range, but that's fine. And then always make sure to check the chart output. That'll give you the histogram, the actual histogram that you're looking for. So whenever you do, when you do that, as you can see here, we have the histogram. It again repeats the bin range, and it gives you the frequency. I don't need this more class, so I just select it and press delete, shift cells up in this case. So that'll give me the actual histogram of, so that actually would be the answer to part A of this question. Finding the distribution, frequency distribution table and frequency distribution graph or histogram. This is the answer to that. And then the second part of the question was to comment on the skewness of these graph on this histogram. For that, sometimes it's easy. You can just look at the data, look at the histogram, and basically comment on the skewness. It looks like that, as you can see, the last class, the last bin, we don't have any observations. So it feels like the data file, the histogram is slightly skewed to the right side. And skewed to the right, meaning that there are very, very few data points to the right side. But like I said, slightly skewed to the right. But it looks like it's pretty close to the symmetrical distribution. But if you want to support your observation, you can always use skew function here, skew, and then put the value of your, basically your data points here, skew of your data point. If you get a positive number, if this skew function returns a positive number, that means the distribution is skewed to the right. If it gives you a negative value, it means that it's skewed to the left. And it's pretty close to zero. Zero is symmetrical per normal or symmetrical distribution. It's pretty close to zero, but still it's positive. So you can say the distribution is slightly skewed to the right. It's pretty symmetrical, but still. The third part of the question says what other observations you can make about the distribution of SAT scores on this sample, on this specific sample. So this is pretty, again, this is pretty straightforward. You just need to look at the histogram and look at the, usually to answer these questions, you just need to look at the two tails of the distribution at the left side and the right side. So you can say no SAT score above a score of 2200. So nothing between 2200 and 2400. So that's one observation, for example. And another one might be this only, I guess this is one. So for histogram, you can always, for any graph, you can always, if you're not sure about the number of frequencies, you may want to add some data labels here. So I just put it, data label outside in. So nothing at the last one between 22 and 2400. Only one between 2000 and 2200. Only one score between, only one person got a SAT score between these two. Only two people, you can see here, and only one person got a score between 800 and 1000. Only one between 800 and 1000. So these are the observation, you can comment on the range, you can comment on the maximum, you can comment on the minimum. Another thing that usually when you're looking at the distribution might be interesting is looking at the most common bin. So what is the most common range of score between 1400 and 1600? So most common score group, most common score is between 1400 and 1600. And observations like these, you can just look at this histogram and look at the tails, look at the center, and look at the range and make some comments here. So that's basically an open-ended question.